Okay, this is the second video for section 6.2, looking at solving a triangle using the law of sines. And really quickly, that's just sine of A over A equals sine of B over B equals sine of C over C. In these ratios, let us solve out a triangle, which is our goal here. We did one example in the last video, and I just wanted to do another one in this video. So suppose we have this triangle. Angle A is 29 degrees, side A is 7, side B is 10. What do you get? Well, we'll just draw a triangle to get an idea. Again, these don't have to be perfect. They're just a sketch to give us an idea. Side A we'll say is 29 degrees, which means angle A is 29 degrees, which means side A opposite it is 7. We'll call this angle B, which means this side opposite is 10. And then that's C, and that's lowercase c. Now we want to solve this out. We said last time, in order to do this, we need at least one ratio of an angle to its side. And there we go, we have that right there. And then we have this side, so using the law of sines, we can find that angle. So set up my ratios. Sine of 29 degrees all over 7 equals sine of B all over 10. Cross multiply to solve for sine B, and you get 10 sine 29 degrees all over 7 equals sine B. So again, you guys know the drill. Throw it into your calculator. And where did my calculator go? There it is. So let's see, we get 10 times sine of 29 degrees divided by 7, 0.6925. So sine B equals 0.6925. Now take the sine inverse. So 43.8. So B equals 43.8 degrees. We can stick that right there. B is 43.8 degrees. But we said last time there's a potential problem here. There are actually two angles that give me a sine of 0.6925. One in the first quadrant, one in the second quadrant. The first one in the first quadrant is 43.8. What's the one in the second quadrant? Well, again, we said last time to find that angle, 43.8 is my reference angle. So to find the angle in the second quadrant, we just do 180 minus 43.8. 10 minus 8 is 2, 9 minus 3 is 6, 7 minus 4 is 3, and you get 136.2. And the question, like last time, is which of these is correct? Is B 43.8 or is B 136.2? And the problem is, in this case, 43.8 certainly seems to work. We said the check you can do is add up the two angles you know. If you add these up, you get about 73 degrees. That certainly allows me to find an angle C and get a triangle. If I use 136.2 and 29, well, if you add those up, you get about 165. That still allows me to find an angle C that will make them add up to 180, which just means we don't actually have one triangle here. If this is all we know for our angle A and sides A and B, we don't get one triangle, we actually get two. As far as solving it goes, I'm not going to take the time to do all of this out because it'll be redundant really quickly. But essentially, you just have to solve the problem twice. First off, for our first triangle, we'll say B equals 43.8 degrees. Now solve the rest of the triangle, and we'll just use this one as a guide. So for this triangle, maybe I'll draw this one in red to match it up. Let's see, if this is 43.8, and that's 29, then so far we have 72.8 degrees. So then what would C be? Well, it's 180 minus 72.8 degrees. 10 minus 8 is 2, 9 minus 2 is 7, that's 0. You get 107.2 degrees. So we can say C is 107.2 degrees. By the same token, I can now find lowercase c. Just use the law of sines one more time. And I get sine of 29 degrees all over 7 equals sine of 107.2 degrees all over C. Cross multiply, do your algebra. We did this last time. You get C sine of 29 degrees equals 7 sine of 107.2 degrees. Then just divide by sine 29. C equals 7 sine of 107.2 degrees divided by sine of 29 degrees. Throw it into your calculator and solve. And you would get, let's see, 7 sine 107.2 divided by sine 29. 13.8. So then we would say side C is 13.8. Now we have all three angles, all three sides, and we've solved our triangle. Or at least we've solved one of our triangles. But we said 136.2 is another possibility. Then all you would do, and here's where I'm almost out of space, so I'm going to have to erase everything. We would just erase all of this. And let's see, on our triangle, well, we're going to change B, which will then change C, which will then change this C. And we go back to this step, and now, instead of letting B be 43.8, we say 136.2 also works. So I'm going to let B equal 136.2 degrees. Put that in here. And now, this is where I'm going to stop and let you guys go from here. Now, I have two different angles. I can still find C, just subtract these from 180 and that'll be C. And then once I get this angle C, I can apply the law of sines again to get this C. The trick is to understand, sometimes you get one solution, sometimes you get two solutions, and as it turns out, sometimes you can actually get no solution. As a quick little guide, I'm not going to take the time to do the math on it. You guys can mess around with it on your own. Essentially, if I get to this point, when I do all my cross multiplication for a ratio, say for this one, if sine of B, instead of being 0.69, it was something like 1.69, well then what would the inverse be? We know sine is between -1 and 1, which means this wouldn't exist. Your calculator would say domain error or does not exist or error of some sort based on what calculator you're using, because that angle doesn't exist. And then we just say, oh, I guess this one has no solution. The key point is to know the law of sines. Sine A over A equals sine B over B equals sine C over C. Be able to draw a rough sketch of the triangle with the information you know. Find the one ratio you know for sure, in this case, angle A to side A. And then from there, build another ratio and solve step by step. Each step, as long as you know your trig and your algebra, each step will determine what you do. If I got the sine to be greater than 1 or less than -1, oh, that doesn't work. No solution. Oh, if I solve it all out and I get an angle like 43 degrees, check it. If it works, we're good. You might only get one solution. But remember, sine can be two angles, one in the first quadrant, one in the second quadrant. So do 180 minus the angle you get from your calculator and see if that one will work. If it does, you get two solutions. If it doesn't, you only get one. Okay? You will do a bunch of these for homework. They become pretty straightforward because it's really just solving proportions, which you all know how to do. I just wanted to go through a few of these so we could see some of the possibilities. I'm going to make one more video showing one more trick that we can actually get with a little bit of this geometry.